So basically, when we talk about the vertical motion under gravity, it is not very different from the concepts we've been doing. There's only one change, that acceleration is now equal to free fall, which is 9.8 meters per second square. So in this case, the motion would be vertical. For example, we say that we drop a stone from position A and it falls. Suppose it passes through position B and then it passes through position C. So all the time, because it is free fall, acceleration is equals to 9.8. Initial velocity at this stage is 0, final velocity at this stage is unknown. So definitely something should be given, either time from A to B to solve for unknown, or the distance from A to B. And no other difference in the concept, as we've been solving from A to B to C in 3 stages. The only difference is vertical, and gravity is equal to acceleration. One of the example question, then we'll move on. A book falls off top shelf of a bookcase. The shelf is 1.4 meters above the wooden floor. Find the time the book takes to reach the floor. So 1.4 distance is already given. Initial speed as it falls, so that was at rest, is 0. Final velocity, time taken, final velocity is unknown. Displacement is given. Acceleration is already known because it is under the action of gravity. Initial velocity is known. Time is unknown. So just plug in the formula and substitute the values. Displacement goes there, initial 0, this gets 0, acceleration is there, and you get the time the book takes to touch the ground. B part says the speed with which the book strikes the floor. Now at this stage we know the time as well. And so again the formula, final velocity is equals to initial velocity square. He's just rearranged the formula. 2as equals v square minus u square, and there you go. We could also use v equals u plus at, because we know the initial speed, we know the acceleration, we know the time, and we can find velocity. Now a little of the new concept, that when you throw something upwards, when it reaches its maximum height, speed at that point is always equal to 0, and then it comes down, and remember that at the same horizontal level the speed is always same. For example, it has speed x here. When it comes down on the opposite side, speed is again x. Speed y here, speed is again y. So still example questions or exam style? Okay. Question number 11. A particle is projected vertically upwards from point O with speed u. 2 seconds later it is moving upwards and its speed is 1 by 3u. Find the value of u. Okay, now the particle is moving upwards. Speed at this point was u. Speed at this point was 1 by 3u, but we know that time is 2 seconds. We know one more thing, acceleration is negative 9.8 because it is moving against the gravity. So when we need to find the speed, what do we know? Is time, acceleration, and speeds. So if I use v equals u plus at, in place of v I substitute this final velocity as u by 3, in place of u initial velocity as u, in place of acceleration minus 9.8, and time is 2. So you see the only unknown here is u. So we rearrange 9.8 times 2 is 19.6. I'm taking it on the left hand side, and then u by 3 subtracted from 1 is 2 by 3, of u. So 19.6 times 3 divided by 2, and value of u is 29.4. B part. The time from the instant that the particle leaves O to the instant that it returns to O. When it leaves O and returns to O. So this is the situation. It left with speed 0, U returns with 0, and the highest point speed is 0 meters per second, and I already know that it is 29.4, and we know that the acceleration is minus 9.8, and we need to find, sorry, it was the time from the instant the particle leaves to the instant it returns. So total time of flight. So if I solve for this first part and then for the second part, t1, my initial speed is 29.4, final speed is 0, acceleration is minus 9.8, so v equals u plus at, final 0, initial 29.4, this is minus 9.8, and time is unknown. So time is equals to 29.4 by 9.8. That leaves us with 3 seconds. So when it takes 3 seconds going up, it takes 3 seconds coming down. So the total time is 3 plus 3, that is 6 seconds. Clear? Question number 12. A ball A is thrown vertically downwards with speed 5 meters per second from top of a tower. Okay, let's just extract the data. Question 12 says a ball is dropped downwards with a speed of 5 meters per second from the top of a tower block 46 meters above the ground. So this tower's height is 46 meters. At the same time as A is thrown downwards, another ball B is thrown vertically upwards. That was A, and this is B, which is thrown upwards with a speed of 18 meters per second. The ball collide. Find the distance of the point where A and B collide from the point where A was thrown. So yeah, that's it. For example, they collide here. So at that time, whatever the distance traveled by A is, let me say that is distance traveled by A is ut plus half at square. This is one of the option, and other could be, let's say we use this. So for B is ut plus half a t square. So time is also unknown. It takes this distance and this takes this distance. Final velocity is unknown for both of them. And another option is v square minus u square equals 2as. Final is again unknown. V square minus u square equals 2as. And v equals u plus at. V equals u plus at. A ball is released from rest. 13 says a ball is released from rest at a point which is 10 meters above the wooden floor. Each time the ball strikes the floor, it rebounds with 3/4 of the speed. That means 75% of the energy with which it strikes the floor. Find the greatest height above the floor reached by the ball the first time it rebounds from this. Okay. So that's right. So the ball is released from 10-meter height. This is 10 meters. Released, speed is 0, final velocity is unknown, acceleration is 9.8. So we can find the final velocity. V equals u plus at. I'm not using this t, so we can use v square minus u square equals 2as. So final velocity is unknown, initial velocity is 0, 2 times acceleration is 9.8, displacement is 10. So v square is equals to 2 into 9.8 into 10, that is 196. Square root 196 is 14. So it hits the ground with 14 meters per second. That is 14 meters per second. And it says the first time it rebounds. So that was 75%. So first rebound is 75%, 3/4 of 14. So 14 into 3/4 is 10.5 meters per second. The second time it rebounds from the floor. So it dropped. This is the first rebound. Speed here was 0. Speed before it hits was 14. Speed with which it left is 10.5. Considering no energy losses, it reaches a speed 0 right there, and it should hit the ground with 10.5 again. And the second rebound is 3/4 of 10.5. Second rebound, 3/4 of 10.5 is 7.875 meters per second. Anything you need to ask? Is this clear? I just skipped that and I found speeds. So distance, that's not an issue. After the first rebound, this is the distance. So I know the initial speed, I know the final speed. Final speed is 0, initial speed is 10.5, and acceleration is minus 9.8. So we don't have time, so we avoid that, and we use v square minus u square is equals to 2as. So I need to find s, making s the subject is v square minus u square over 2a. So for the first rebound, v is 0 minus initial is 10.5 squared over 2 into negative 9.8. So this is finally positive, and that is 10.5 squared divided by 2 into 9.8, and that is 5.625 meters for the first rebound. And for the second rebound, it rebounds with this speed. So same, I'll just write the formula and place the values directly. So rebound final speed is 0 squared minus 7.875 squared over 2 into minus 9.8. And we get 7.875 squared, that is 3.16 meters. Let's see if we get the same answers. This is 2F. Question 13. 0.2F. This is 2F. 5.6 and 3.2. So yes, 3.2 and 5.6. Correct.